Is our virtual start party for December 16th of 2012. I am Scott Lewis, and with me tonight is Nicole Gugliucci. The parents are away. I mean, Pamela and Fraser are off on a cruise, or are actually about to leave on their cruise tomorrow for not the end of the world. So we are filling in to have some fun. Unfortunately, we've also had a large amount of weather problems throughout the Northern Hemisphere, so all of our astronomers have been clouded out.
Apparently the entire world is clouded out right now, except for Teale. He
Because
is the only one with a telescope that is not clouded out. So, thank you, Teale. You are awesome.
You are awesome. And so what we'll be doing instead is... Yeah, absolutely. And Teale is one of our wonderful astronomers that we've had throughout our many virtual star parties. So we'll be having Teale showing us the sun throughout the entire star party, if he's down for it. And Nicole and I will be going through a tour of the solar system, as well as Nicole will be showing some of her radio astronomy done at wavelengths that we don't typically get to see. So
I've been wanting to do this for so long. Yeah, I'm like, oh my god, I can show radio. I mean, they're not that great. It's fine. We can totally show your cool astrophotography pictures if you want to share them on the event. It has to be your image, though, that you've taken for astrophotography, and we will be happy to share that as well, screen share that to the whole audience. So you can add that on the event page. Up at the top, if you're on the event page, up at the top there's a red button that says Add Photos. And so you can add your astrophotography and we'll share it with the group. Like I said, I'll share some images I've made with radio telescopes. We'll have the sun in the background for those of us for whom the sun has set, so we can be like, yay, it's warm and stuff. Yeah.
So we're getting this through. I'm just making sure I'm playing producer and host at the same time, so don't mind me as I'm jumping all around with the YouTube stream. But one thing that I will be showing off today is this awesome program called Celestia. Now, typically I use a piece of software called Stellarium, but we have the ability to use this other piece of open source software, to take a full tour of our solar system and beyond. So here is a 3D model of our sun within our solar system. And we're able to take a look at all the orbits, which are those blue lines that are going around, making sure it's going through. But we can also take a look at, let's see the Earth, for instance. So I'm going to go ahead and center on the Earth. And let's travel there.
So Celestia is free, you said?
Free.
It's open source.
Yep.
Planetarium software. So, yay for that.
And what I really love about this is that we can even see the ISS and we can track it. So let me get in there. I'm going to go through the Earth for a moment. Get on the other side of the Earth. I removed the ground in Stellarium. I can go through the Earth with
We're
this.
neutrinos now! Yay!
That's right. So there's the ISS, our lovely
question,
tin can.
quick, because I was wondering, this is where is Teale located that he's showing us the sun live?
Yes, where are you, Teale?
Hello, audio.
I'm in Brisbane, in Australia, so on the east coast.
Cool. Okay, so yes, that's why he can see the sun and we can't here in the U.S. Okay, sorry to interrupt you. I just saw that.
No, that's fine. I'm actually typing commands and going to awesome places.
Yeah.
So,
and yeah, I think we should point out, if you want to leave us questions, we will talk about any astronomy topics, possibly, that we can pull out of our brains that you want.
Out of our brain mates. We are a little frazzled right now as we're getting everything going, but we love being able to work with everyone and answering questions. And anybody that's on there, please make sure to refresh the event page. I will make a comment to that as well.
People have,
So yeah, again, we're wishing that we could have some live images, but what we'll do instead, we'll be going over this wonderful piece of software that's available for everyone, and to get a better intimate look at where we are and what's our initial surroundings. And later on, we'll go a little bit out to scale and see things perhaps that Nicole has observed with her research with the non-visible spectrum. She uses much bigger telescopes than any of our astronomers do.
Mine's the size of the world. It's not mine, but whatever.
It is.
I've applied for time on it.
And are you going to be doing some more here soon?
Me what?
Will you be observing some more here soon in the future?
I don't know. I still, we were chatting earlier today, I still need to publish my dissertation research. So I've got that all observed and done, and I just have to put it in an actual scientific peer-reviewed publication and get that done. I gave a poster at the American Geophysical Union fall meeting a couple weeks ago, which kind of helped restart my brain thinking along those lines.
Right.
So, yay. We have a question from Graham about the Helix Nebula, which I can screen share a picture of somewhere. And you're asking if the Helix Nebula is actually shaped sort of like an eye. And let me see if I can screen. Do you have a picture of it?
I can pull one up. Let me...
Wait, I'm gonna beat you to it.
All right, please do, because I'm like 8 screens.
Although it's like, yeah, it's totally like Wikipedia. Thank you, Wikipedia, for showing this picture of the Helix Nebula. So this is a planetary nebula, meaning that it's the end period of a star's life, similar mass to the sun, so not big enough to go supernova. But something that's a bit smaller, and it slowly puffs off layers of gas as it's near the end of its life, as the fusion in its core dies down. And often these planetary nebulae don't puff off in a perfect sphere. You actually get something that's in this case, astronomers actually think it's elongated, kind of like a football shape, because due to the interactions of the stellar winds. I'm like talking with my hands, I actually have to show. Due to the interactions in the stellar winds, all that fun stuff, it actually makes it so that it's not a perfect sphere as the gas comes off the spherical star. The winds could make it stretch out in a certain way. There are some planetary nebulae that look like, yes, it is the Eye of Sauron. Thank you, Alex. There are some planetary nebula that look, there's the Hourglass Nebula, and it actually kind of puffs off in 2 directions. Not really jets, but kind of what I'm doing with my hands. It puffs off.
What are you doing with your hands?
I'm making an Hourglass Nebula. Come on.
Oh, there you go. I was thinking the Itsy Bitsy Spider Nebula.
Itsy Bitsy Spider. I'm sure there's one of those too. But yeah, the material kind of comes out in these 2 big waves away from the poles of the star. And it has to do with stellar rotation, stellar winds, all the messy part of astrophysics that goes on. And so yeah, the Helix Nebula is indeed not a perfect sphere. It's elongated. And yeah, our viewing angle to it obviously changes what it looks like to our point of view. So yeah, thanks for your question about Helix Nebula, aka Eye of Sauron.
And actually, I see one here from Craig, and he's asking me about how to use Celestia. Especially if you use Stellarium, it's a little bit different as far as some of your keyword shortcuts. And so instead of doing Control F to find an object, what you'll want to do, Craig, is push the Enter key, and at the bottom you'll see where to type in the target. So right now I'm on Mercury, but if I wanted to go out to Jupiter, for instance, type Jupiter, press Enter.
You pressed Enter?
Enter, Jupiter, okay. Enter again. But obviously we're not looking at Jupiter. So you do C, the letter C to center, to actually find it, and then G to go. And then
we're flying to Jupiter, guys! We
just flew to Jupiter.
But it's really cool. So I've used a program that is not open source and free, but I've used Starry Night and Starry Night Dome, which also allows you to do this. If you are an organization that can buy one of those big inflatable planetariums, you get Starry Night Dome with that, and you get to do all this flying stuff inside the dome, and that's really fun.
It is, so because it gives you just a different way of being able to understand. It's great to have like a celestial sphere, or to have some star charts, but to actually have your own planetarium around you is always great. And then this is a great way for, it's free at home. I'm not sure if it is available for Mac or Linux. I'll have to check.
Celestia.
I know that Stellarium is, but Celestia, I'm not sure if it is.
Princess Celestia loves all.
Yes, she does. Now, we're going to hop back to Teale real quick. Now, I know earlier we're having some... we were having a little bit of detail going on. Are we able to get a little bit more there, Teale?
Ooh, I see some spot, I think.
Yes, you do.
I think that's about as much as you're going to get.
Okay.
Because I've cranked it up to the maximum resolution now, so it's obviously something in the network connection, I'd say.
Right.
Well, and to be fair, you are using somebody else's telescope, from the shop, so you haven't had a lot of time to actually play with it. So for just taking it from the shop and hooking up your camera and getting it running on the very last minute, it's phenomenal. And it's great to be able to take a look at our closest star. It's really easy to forget what's the closest star to us. Well, it's not Proxima Centauri. It actually is our sun. And that's a big reason why we're able to know so much about other stars is by studying our own sun. So we can take that knowledge and compare it to other stars of similar mass and spectrum and have a better understanding of what's out there and see what the changes are going on with those. So we study things that are up close to us so we can actually be able to better understand the universe, no matter how far away everything is. What exactly were you studying, Nicole? I know you did some awesome stuff.
Which thing are we talking about?
With your research, your dissertation?
All the things.
All the astronomy you've ever done.
All the astronomy I've ever done. So I primarily did radio astronomy as a grad student and as an undergrad when I did some REU projects. If you are an undergraduate in astronomy, you want to look at the research experience for undergraduates because it is the coolest thing ever. You'll go somewhere for a summer and they'll teach you how to do research, basically. It's especially good if you're at a school like I was that was small and didn't have a big research department in the school. So I got into radio astronomy through that, and the things that are my favorite things to look at are radio galaxies, and specifically the kinds with the jets that, spew material out from a supermassive black hole in the center. And I can show you some not terribly good pictures. I went through and found some of my old publications, and I made lots of like contour plots for the publication. They're not like pretty images in any sense, but I could find a couple more of those as well. If you want to look at really pretty radio pictures, there is an image gallery for the National Radio Astronomy Observatory. It's images.nrao.edu. And so my favorite things to look at, let me see if I can find my favorite picture. This is like everyone's favorite picture, but that's okay. Let me open up the large version. No, that's not good. Ooh, here we go. So, obviously, when people ask, is that real color or false color? If you're looking at a radio image, yes, technically it's false color because, tell me what the color of radio should be, like, you can't. Yeah, so in this case, they colored the picture where yellow is the most intense, the brightest part of the picture, and it fades to orange and red as you get away from that. So this is Cygnus A. This is one of the brightest radio sources in the sky. At some frequencies, it's even brighter than the sun, so the sun's not really a big deal down at low frequencies. And in the center, there is a supermassive black hole. Someone dinged. Okay, the center is a supermassive black hole, and that is something that's, I don't remember the actual mass of this one, but it's a few million to a few billion times the mass of the sun. Black hole in the center of a galaxy. You can't see the galaxy in this image because this is only the radio light. And so what you can't see is that there's actually a galaxy with all the stars and gas and stuff you're used to seeing. But there's this gas, it's electron and positrons that come out in a collimated jet away from the supermassive black hole. This is the stuff that can't get in. It actually gets pushed away in a thin jet. And this one in particular, it interacts with the intergalactic medium out here and just lights up once again. I mean, I could really dork out about synchrotron radiation and how that's made, but I will spare you guys tonight with the super dorking out. But all of these electrons get re-excited by collisions and glow in radio and in X-ray. They glow in all kinds of wavelengths, but don't necessarily see this in optical. So this is made with the Very Large Array. That's that Y-shaped array in New Mexico. That's the infamous Jodie Foster with the headphones picture that all of us copy, even though you don't listen to radio telescopes, but whatever.
So that's do that top 40 out there for you to tune into?
No. But you can actually. Okay, so scary. you can get certain. But you can. Last time I was out there, you could get radio station reception and occasionally cell phone reception. It's less of a problem there because there are 27 telescopes. You can get rid of the man-made radiation pretty easily because of the way you process the data. Mm-hmm. Something like the Green Bank telescope, where it's one dish just collecting radiation, collecting radio light. There are no cell phones, and they actually have a specific radio quiet zone that is around that area of West Virginia where there can't have cell phone towers, you can't have Wi-Fi.
Well, it makes sense. I mean, it's like having a dark sky sight. It's just a different type of light that we're using. So our cell phones are using light, just at a different wavelength.
If you had radio eyes, you would see this, glowing right now, even from the back when I've just turned it on because it's giving off. It's trying to find a cell phone signal, but I'm in the basement, so we can't find one. You would see this thing glowing.
Yes, they put Noisy in the dungeon.
Yeah, they did. Behind metal filing cabinets. It's great. So that's a brief introduction to radio images, and that's one website you can go to look at. And I think it's cool because you can see the universe in a different light. Literally, you can see what our eyes can't see. I mean, when radio astronomy was pioneered in the 30s and 40s, it really gave us a new window to see the universe through. And you can do it from the ground. You don't have to build a space telescope to do it.
Yes. Now,
and we have a
Dad is here.
Hey, Nicole. Hey, Scott.
Hi.
Hey, Teale. Hello.
Now, I know that you've done some research as well, obviously. What type of equipment did you use for your research?
So, actually...
Hey, how are you?
Oh, how you doing, Teale? I used the Sloan Digital Sky Survey, so it wasn't in any equipment that I even really had to run or do anything with, but there's data that's publicly available if you go to sdss.org, or I guess at this point they're onto sdss3.org. There's some tools for a database that you can just query. It's like, I want all the galaxies. And so it's, and
literally, yes.
So that's basically the query I had to run. Now, galaxies with what's known as good photometry, meaning that we have a good idea of the magnitude of the galaxy in at least one visual band. But yeah, I mean, you can kind of cook with whatever you want. In fact, there's a FAQ out there that's called Cooking with Sloan. Nice. So if you want quasars, okay, here's the query to execute to get all the quasar data. So yeah, I didn't actually have really hands-on with any kind of equipment other than computers to grab all the data and process it. Now, I was doing work in helioseismology before switching to cosmology, so I did get a little bit of time at the 60-foot tower at Mount Wilson, and I actually got to see both the HMI and AIA instruments when they were on the table at
oh, that's cool.
Being tested before being launched on SDO. So that was my first bit of
a bunch of
research.
Letters, and I'm sure a bunch of others.
Okay. So
SDO is something that a lot of us are familiar with, the Solar Dynamics Observatory, with Camilla, our awesome chicken friend.
Yes. Okay. So AIA is the instrument that does all the mostly ultraviolet imaging of the sun for SDO, although there are a few infrared and visible light wavelength cameras with it. Most of what it's looking at is this higher energy radiation, so trying to follow the loops of plasma around the magnetic fields of the sun. So I mean, we have this view that Teale is providing of visible light sun. But if you look at higher energies, for instance, if you go to spaceweather.com and you scroll down on the left side of the page, you'll see the X-ray picture of the sun. and there's just way more activity visible from the hot plasma arcing above the sun in that wavelength. So, even if the sun looks completely quiet sunspot-wise, there's still magnetic activity there, and you really need these shorter wavelengths to be able to see it.
Yeah, it's quite amazing, especially with the surface of the sun being around 5,800 Kelvin. All the stuff that's going on in the outer edge is actually much, much hotter than the surface of the sun, which is causing a lot of that activity going on.
Right. So, and that's one thing that seems kind of counterintuitive to people is that, all right, well, there's spots on the sun, so this means it's putting out less light. Actually, no, it's up, in the amount of energy it's giving off. Now, it's a tiny, tiny fraction. It's like less than 1/10%. But because these active regions are putting out so much more in the ultraviolet and these other wavelengths, that when there's sunspot activity, the sun is actually putting out more light, even though it has these dark patches on it. It's just less, a little less visible light, but much more of the higher energy. Well, not much more, but more of the higher energy light. So,
awesome.
Looks like we got some prominences from Teale now too.
We do. Put that back over there.
Speaking of loops of hot gas and plasma
there's
above
actually
the
quite
sun,
a few on the edges today.
Yeah.
So what we mean by the prominences here is, you're actually seeing the loops coming up and off. So when you see those amazing pictures on the internet about, all the flares coming off, you're actually seeing matter coming off the sun being looped in with the magnetic, because it's very tumultuous. The magnetism happening on the sun is actually really, really awesome to see the magnetic field going on. It's always twisting and turning about.
Yeah, it's one thing. I mean, I was at a series of seminars for helioseismology, and one of the last lectures was, full-blown mathematics behind magnetohydrodynamics, which is, essentially what you need to predict where plasma, the large-scale behavior of plasma on the sun. And that's some hairy math. That is some really hairy equations that are tied together at some very basic levels, really hard to kind of tease apart. And this is something else that we kind of saw, is that most of the predictions for this past solar minimum and this coming solar maximum had said it was going to be fairly intense. Then we got more data back from the GONG project from MDI, the magneto-Doppler imager on SOHO, and after being able to model it better, we've seen that no, it's actually a very small solar maximum we're having now, and that the sunspot cycle essentially died out completely for about 3 years there, from 2007 to 2009. There were almost no spots.
And what's great is, if anyone's ever in the Los Angeles area, you can actually go up to Mount Wilson Observatory and go into their solar tower, and every day you can actually watch them do it. And they'll put in a nice big piece of paper, and they'll actually sketch the sunspots, and they go through, and you can actually see the full, a full week, actually a full month, and you can actually watch the rotation of the sun happen based on where the sunspots are happening. So that's one big thing too. We see that the sun is not only this amazingly hot, bright object, but it's something that is rotating as well as doing much other activities as well.
Although with the feeds from SDO on any one day, I mean, essentially it's taking a picture of the sun every 45 seconds, full 4,000 by 4,000 pixel picture. So you can get cleaner rotations, definitely, from seeing from there. And also, I mean, you don't have Earth's atmosphere blocking the UV rays. So
you do learn something when you do it yourself.
Okay, right. Yes. And of course, this is where it's been done. Yeah, it's definitely a good lab. It's definitely good for even the historicity of it. That, the first solar telescopes in the U.S., the Snow Telescope, the 60-foot tower, the 150-foot tower, were all up on Mount Wilson. And they still do provide data for some of these ground observations. So, if you can get to Mount Wilson and get a tour, you definitely should. So
I know. I need to get out there. I need to get out there.
Are you coming out for AAS?
I am. I will be in Long Beach.
All right.
But the road will be closed up to Mount Wilson.
Yeah.
They typically close between November and March. Because, well, you know what it's like driving up there.
Yeah.
It's not a fun drive. Well, it is a fun drive, but right now with all the rain we've been having,
yeah.
I've done my share of crazy mountain telescope drives, so it's.
Well, they originally
I'm okay with that.
used this on they use mules to build and to get everything up there. So it's you think having jackknife switchback turns is nothing. You're looking over a cliff as you're driving about. It's insane.
Yeah, no, I've done that.
Yeah.
Awesome.
You see the car that's gone off the side of the cliff and has been there since the 60s. We had one of those at UVA. It's great. It was a washing machine off the side of the road. It was nobody ever knew the history. Nobody knew the history of that. If someone knows the history of that, please tell me. But yeah, UVA had some fun stuff off the side of the mountain. On the way to our telescope.
That's awesome. Well, I just heard from Peter Lake as well that he should be joining us soon.
Yay!
He is getting a little bit of a clearing in his skies. He's also in Australia, but he should be actually observing from New Mexico from his eye telescope. So he actually is a partner with them.
Excellent.
And has his telescope in New Mexico, so he should be joining us momentarily.
I just wanted to go back in the stream a little bit to the comments. Chris asked, when I was talking about planetary nebula, hopefully I didn't completely botch that explanation, would large planets cause distortions in the shape of the gas as it is expelled? I don't think so. I don't think they're massive enough. I know, I had a friend who was working, my friend Jolene, not Miller, married name, Jolene Karlberg, who was, her dissertation was on looking at stars that had swallowed gas planets, and so that changes the spin and the chemical composition a little bit. I don't know if having a large gas giant out there would significantly change the planetary nebula. I'm sure someone has simulated that. But my guess is no, but I'd have to see if someone simulated it. I'm not sure. And a couple people chimed in that Celestia, the software that Scott is using to give us our 3D, that we keep interrupting his 3D tour of the solar system.
No, this is something for fun. Oh yes, the dungeon has taken over, and it's now nighttime for Nicole.
Okay, there's the lights are, like in most university offices, they're motion sensors, so if I don't and there's no one else in the labs right now because it's 8:30 on a Sunday night, so the lights go out. Anyway, Celestia works on Mac and Linux. That's the point I was trying to get to.
Okay.
So yeah, there's a couple of other questions that I saw. I know I'm missing some of them.
I do see one, Guillermo. Lessa, we are checking these comments, so it's not a shame. We are checking them, so please feel free to make YouTube comments. We have comments from all of Google Plus and Twitter and YouTube, so we are checking them, going through them. So please keep making your comments. We'll try to do as much as we can, especially if Peter comes in, we might be able to get some requests going on as well.
Woohoo! We can finally see things in the night sky and not just the sun. I mean, I love the sun, don't get me wrong.
Wow, Teale, she just thrown you under the bus. Man.
Oh, no, I'm a big fan of SDO. I was at the launch. I love it.
Very
Tommy Wu asks about the supermassive black hole in NGC 1277, and how does that impact or change our current understanding of models of supermassive black holes? So I had to look this one up. I was not familiar with that name off the top of my head. Apparently its black hole is something like 14% the mass of the entire galaxy, which is huge.
Yeah, that's unbelievable. I mean, typically it's less than 0.1% of the mass of the galaxy. But yeah, this is something, a recent finding where, that's, that's
really recent.
Just
Next
huge. I mean, it's
absolutely.
And so, I haven't read that much about it either. Actually, a couple of my students brought it to my attention this semester. They're like, "Hey, have you seen this article?" And I was like,
"I totally missed that one because that was around Thanksgiving. I was traveling." Yeah. That's pretty crazy. Like you said, it's 0.1%. I mean, we talk about the supermassive black hole and whatever. It's like a tiny nothing gravitationally on the scope of the galaxy.
Yeah.
But if it's 10%, that's a significant fraction, and it probably did form in a... We're not entirely sure how the black hole galaxy thing, it's kind of that chicken and egg problem, which came first. It seems that they definitely evolved together. The larger galaxy you have, the larger supermassive central black hole you have, that there is a general trend in that direction, but this one is way off that trend, and so it may have been, I don't know. I mean, could it,
I mean, the thing is, if you look at the mass of a stellar black hole, so a star that would or a black hole that would form from the collapse of a supergiant star, those would typically be on the order of about 3 to maybe 30 times the mass of the sun.
Mm-hmm.
So, I mean, here, a supermassive black hole, the black hole itself is millions of times that mass.
Right.
And so, the question is, well, could you possibly assemble a black hole of this size by merging a whole bunch of smaller black holes? And the dynamics there aren't very well set up for it. Unless you're within about 6 times the radius, the Schwarzschild radius for a black hole, you're not going to have that degradation of angular momentum that could drag something into the black hole. Big misconception about black holes.
They're just going to tend to kick each other. You have multiple gravitational body interactions, and they're just going to start kicking each other out. And so
exactly.
They can't all just get sucked in.
And make that noise as they do so.
That is the technical term, by the way.
That is the exact noise. Yes. I do this for my students too, and it's like So, but yeah, I mean, that's what you'd imagine. If you were in space nearby, and space-time is, it's squishing together like that. So, so what's more likely is that you had some fluctuations in the density of matter from the early universe, and that they accumulated, and instead of becoming a star, that there was enough matter in one area that just directly collapsed into one of these enormous black holes.
Right, and that those coming together over time, as smaller galaxies merge into big galaxies, would have created the supermassive giants we have today.
Yes.
But you need to have built a big galaxy out of smaller galaxies to get that. How did you build a big black hole without building a big galaxy? Like,
right.
That's the question in this case.
Yes.
So the formation mechanism, I mean, we could speculate, but I'm not even... I haven't read the paper, so I don't want to speculate too far in that direction.
Yeah, I think
read the paper.
I think I've just read, yes,
I'm so behind on my astrophysics.
Science for the public kind of regurgitations of what was done. So
don't even get me started.
Yeah. I mean, at least well-written ones, as opposed to
Yeah, there are lots of written ones. Some of them I just don't understand.
But yeah, I haven't been able to read the AstroPH for it either. So
yeah, we need to. I'm so behind. By the way, AstroPH for those all of you except for me and that. That is the daily list of preprints for papers that are published in scientific journals. So because there's a huge barrier for getting for reading scientific journals because they're really expensive, so usually an institution has to get the subscription for it. A lot of physics and astronomers post their preprints before they go into the journal. Into this thing called AstroPH, and anyway, so it's like a daily summary of all the papers that are going into publication in the next couple months. So yeah, we can.
So you can really get your nerd on.
You can really get your nerd on because they're
budget.
Free. Because it's free access to all the stuff that's going to be in the scientific journals anyway, and yeah. So go nerd out.
You have to be a little bit careful of it. I mean, a lot of these are coming from sources that will end up being, passing peer review and being published. But there is some stuff out there where it's like, hey, we got this idea, we kind of played with it, and we're going to put it out here first.
And that's good too. Some of it's good, some of it's not. Some of it's just white papers, like here's the idea. Yeah. Some people put their dissertations on there. I never bothered. I just posted it on Dropbox. Sent out the link. Open source.
But there's more than just AstroPH, too. If you're interested in any branch of physics, and you go to, it's called archive.org, arxiv.org. Any branch of physics that will have preprints available there. So you want to see what's going on in high energy, or condensed matter, or nuclear, or purely mathematical physics, atomic, whatever you want to do, you can go there. Or, of course, beloved to our own hearts, astrophysics. Yes. It's all out there. So.
Yeah, that is open. It's the open science movement before open science was a movement.
Right.
So yeah, we love it. Oh gosh, we're probably missing other questions.
We are getting some more questions here, which is awesome. I love being able to discuss this. Though we are having just the one object for the telescope, we can actually get a better intimate relationship with what goes on in the science end while we're trying to better understand our universe. And speaking of trying to understand what's going on, we have a question from, I hope I'm pronouncing this right, is Shantanu Jakete. And what exactly happens when an object goes into a black hole? People, I don't believe that's happened yet. Spacecraft, not that either. But when stuff goes into a black hole, what happens?
There are some gorgeous simulations that have been done online. So one is about a cloud of gas, actually, that they've seen that's approaching the... Well, this is the weird thing. I say they see is approaching the black hole in the center of our galaxy. That's 26,000 light years away. So it hit the black hole in the center of the galaxy about 25,999 years ago, if it was exactly 26,000 light years away. And so what we see here from Earth is that this cloud of gas will be... some falling into the black hole in the center, and most of it going into orbit or getting shot out from it later on this year. So, I mean, we'll get some good direct evidence of what happens with a matter encountering a supermassive black hole later on in 2013. Let's see. Another one, though, is Neil deGrasse Tyson's lecture on spaghettification.
Yes.
Which I make sure I play for my students every semester. So...
and not because he likes pasta.
Not because he likes pasta.
All right.
This is the world's scariest pasta maker.
Yeah.
A black hole. Yes. So...
There's also a really great... This is dorky. There's an episode of Stargate SG-1 where they open up the gate to a black hole by accident. And they actually play with the concept of having things redshifted. So if you imagine... someone falling, there's like 2 points of view you can watch. You could say, from the point of view of the person falling into the black hole, you know, they get closer and closer, and they get, you know, the gravitational forces stretch them out, and they become like spaghetti, like your atom of spaghetti swirling around and get...
So if anyone had Stretch Armstrong when they were young, this is what's happening. Yeah.
Right. If you're going feet first into the black hole, the gravity on your feet is stronger than the gravity on your head, so it just rips you apart. But from the standpoint of people watching you fall into the black hole, and here's where redshift comes in. They see you getting redder and redder and redder because the light coming from you is actually gravitationally redshifted. So that means that the light appears to be redder in the spectrum, or red infrared radio. So if they hear you screaming, they're going, "Ah!" And if they're seeing you, your image is actually getting redder. And there's also time dilation. So there's...
Well, real quick, I want to clear something up. Are you screaming in space and hearing the sound in space?
Well, if there's enough gas around, if you have enough gas around you, so that sound can travel to a little microphone, and then you're sending the signal, it totally works.
Okay, making sure
assuming
we're all
you can
clear.
hear sounds in space, you're going, "Ah!" And then you're turning redder, and then there's time dilation, so the people watching you watch you go slower and slower and slower, and it takes an eternity for you to fall in from their point of view. So yeah, there's a whole lot of interesting physics. There's the time dilation aspect, there's the redshift aspect, and then there's just plain old spaghettification from your own point of view, which is what happens to you. That's really quick in a nutshell. I can easily take an hour lecture talking about that. So I have. I have.
Oh, we lost Peter.
We lost Peter, no!
Peter,
He's always yakking about screaming black holes.
Wait, one more time. I don't think our audience got that. There we go. There it is.
We're going to replace
Love it.
notification with we're just going to do it.
Hey, Peter, how you doing?
Peter!
Can you hear us? I think you can hear me, but I can't hear you.
Oh, someone asked what the Twitter hashtag is. It's #StarParty.
Yes. One word, #StarParty.
Super, yeah.
And yes, we're checking them on Twitter.
So yeah, if you can comment on Twitter, with that hashtag, you can comment on YouTube, you can comment on the Google Plus page. We get all of those, and then I think we're watching the event page as well.
Yes,
someone is. I'm not.
and then Tom Nass concluded that yes, you'd be dying of embarrassment when falling into a black hole. Because, well, yeah, if you manage to get yourself in that predicament, I think it's a reason for being embarrassed. Just like if you're flying through the asteroid belt and you happen to crash into an asteroid, you should be a pretty embarrassed pilot because it's not that dense.
Yeah, can we do that in Celestia? Do you have an asteroid belt?
I can. Again, it's not going to be anything like you've seen in the movies, but let me...
But that's what we want to show people. That's exactly what we want to show people.
But Scott, the chances of successfully navigating an asteroid belt are 3,270 to 1.
Yes, that's right.
No.
How did you know?
No, stupid C-3PO.
So I'm going to go to Earth real quick. Is everyone down to go to Earth again?
Sure, let's go back to Earth.
So I'm actually looking at the Milky Way galaxy, and that's where our sun is. Right over here. Let's go.
Now I have to ask, does Celestia represent the Milky Way as a barred spiral, as it should?
I would not call it a barred spiral, but when we get done looking at the asteroid belt, I'll head on over to Andromeda real quick, and we can turn back into our rearview mirror and see what's going on.
Okay.
That's a good plan. So here is our sun, and we have Mercury and Venus. And as most people know, or hopefully you'll learn now, our asteroid belt is between Mars and Jupiter. So I'm going to head on over to Mars and look towards Jupiter. Hello, Mars. Everyone say hello to Mars.
Hello,
Hello to Mars.
So
hi, Mars. How's the wife and kids?
Phobos and Deimos.
This is some pretty scary kids to have.
Yes. They're kind of lumpy.
Lumpy. But naming your kids after fear and panic, I don't know. That's
I think most parents, in retrospect, might have changed their kid's name to Phobos and Deimos.
No, wait, Teale, do you have kids? Because the other three of us, I don't think, have kids. No. Dad, do you have kids?
No.
No.
I have chinchillas.
Close
Does that
enough.
count? Okay.
So,
speaking of which, I gotta be right back. That's right. I gotta take care of something with one of them. I'll be right back.
You're sick to hear the show. I see Peter again.
So we're gonna go to our favorite asteroid right now.
Yay!
What's our favorite asteroid? Best.
Ceres.
Shh. No, not
Mercury.
Ceres. You know better. So here's Vesta. This is the second largest object in our asteroid belt. And she is awesome. If you want to talk to her on Twitter, she is personified via asteroid mappers on Twitter. And she's kind of snarky. And Nicole is laughing for some reason.
No, I'm just remembering the Vesta Mercury Moon conversation we had a few weeks ago.
If you can find that storyfy that Pamela made and share it with our audience, it was awesome. So the Moon, Mercury, and Vesta were having a spat on Twitter, and it is hilarious. But we look here, and this is Vesta. We can see its orbit going through, but there is really not a lot of stuff out here because it's such a large area. And it has a long orbital period going through. So you have Jupiter, which has a large mass, and so you have to deal with its orbital resonance breaking stuff up. So especially in that area, there's not much there. We have Vesta, and then we go on over to our second favorite asteroid, Ceres. And it's so far away. So things in the asteroid belt, you don't have to worry about bouncing back and forth all over the place because, again, if you crashed into anything there, you're a really bad pilot. And if you had to duck and weave between two asteroids, you're doing something really wrong with your spacecraft. And
well, I guess if you're traveling at warp. Wait, if you're traveling at warp,
when was the last time you traveled at warp? I mean, mine's a few weeks ago. And I'm still waiting to see my younger self.
We're going to stick to real physics.
Yes.
Okay, fine.
So how you doing, Peter?
We can't hear you.
Nope, still can't hear you.
No sound.
Yeah, Michael said, 0.5 of light speed through an asteroid field, you could get shamed, yes. But getting to 0.5 the speed of light is insane. We do not have those capabilities of getting to that velocity. It would be awesome, because if we could actually get to that velocity without killing ourselves in the process, or killing any of the machinery with that acceleration, that would be beautiful. We could actually do interstellar travel. But getting that velocity is hard enough, but then dealing with the acceleration and what actually goes on with acceleration to get to that speed, humans can't. We would die. There's no point. We would go squish and splat, and it's no point at the end of the day. But looking at our robot friends that we have all over, it would be great. I would love to be able to do that, but just the amount of fuel or the way of actually accelerating to that speed and without blowing yourself up in the process is just not probable. At least now. Maybe because I plan on living forever, maybe in 100 years when I'm around and I get to pilot this thing because, well, I'm living forever, I get to be a space pilot too. That would be awesome.
You just have to live long enough for cyborg technology.
Yes.
Yeah.
And after Pamela, I'm the next cyborg. Because we've already agreed upon that.
I missed that conversation.
Yes, you weren't there on that conversation. So let's go check our comments real quick as we're going through being crazy.
I did post on YouTube. I attempted to post the link, but of course it blocks links, so I put the dot in there.
Yes.
And on the event page, I posted the link if you want to see Mercury and the Moon and Vesta argue on Twitter.
Yes. They are hilarious. And in case some of you guys didn't know, was it Tuesday? When was your hangout? On Tuesday or Wednesday?
You're asking me? When did I do
yes, the one you were in with Dawn.
Oh, I don't know. I've lost track of the week.
I think it's Tuesday.
I'm at work on a Sunday. I don't know what day it is.
That's true. So
it was Tuesday. Yes, we did the Dawn Vesta hangout with Pamela Gay and Jennifer Scully and Joe Wise, and it was either Tuesday or Wednesday. I still can't remember. And so we went over asteroid mappers. So you can go to the Dawn EPO YouTube page or Astrosphere Vids, which is where CosmoQuest lives on YouTube, and watch that video, especially if you're interested in doing the citizen science for asteroid mappers, because Pamela and Jennifer sit there and actually mark some craters and explain what they're looking at, which is pretty cool. Exactly.
So one thing that we've been working on at CosmoQuest is trying to find a better way of help relating some of the more advanced features to mark, because a lot of times there are some things that most of us didn't know until we learned about them, like albedo feature. What does albedo really mean? And without a really good explanation, I wouldn't mark it if I didn't know what it was. So we went through and tried to make sure we can mark these different features in our Hangout so you guys can actually be able to see what exactly you're marking and how you're able to better contribute to citizen science. So I definitely recommend you guys go take a look at that. It was a lot of fun, and getting to hang out with NASA people is always cool. The NASA people are awesome.
Indeed. Indeed.
Do we have any awesome pictures yet?
I am actually right now putting them on my desktop so that I can put them together and screen share them.
I see James McGee put one up, and I'm excited to share that one later.
Okay.
So James McGee, you're awesome. Thank you for that image.
Is that the one? Is that the one that's at the top now?
Yes.
Yes.
Did you like my Jupiter from what was that, 2 weeks ago? That I had as my image while I was out taking care of my chinchilla.
Yes.
That was cool.
That was awesome.
So went and got a camera that shoots 120 frames a second, so that you can take movies of Jupiter over a short period of time and then stack all the images together to produce things like that. So that was my first try with that camera.
Can you put it back up and explain what you were doing and with your mountain telescope and everything?
Okay.
There we go.
So this was Jupiter from the evening of, what would that have been? December 3rd. And so I've got a 9 1/4 inch Schmidt-Cassegrain telescope. And essentially what most planetary photographers do at this point is they don't shoot single images of planets, they take a movie. And so with the movie you can take the images and stack them together, and it will add up things that are actual features on the planet. It will help reduce the noise that's introduced by, say, our atmosphere. And so that's the first thing. This is stacked from about 4,000 frames of Jupiter, nice. Of which I picked, I guess, probably the best 600 or 700 or so. And then there's software to automatically do the stacking. That's either Registax is one, or AutoStackert is another one. There's also AVI Stack. And I kind of am liking AutoStacker a lot at this point because it does a lot of the pre-processing for you.
Right.
And is a much more kind of turnkey operation instead of having to learn a lot more about the software. I mean, there is a lot that you could learn by diving into it more, but you can get results faster, I've seen from it generally. And then you have to take it through, actually, once it's done with AutoStacker, you take it into something like AVI Stack or Registacks, which have property which are called wavelets. And so essentially what you're doing is you're teasing out details on different levels from your stacked image. And so you can get resolution kind of like what... this is definitely not the best image. This is, like I said, my first kind of shot at it, but the seeing had settled down very nicely. The turbulence in the atmosphere had gone down very well for about a minute, and was able to compile the shot. So,
I knew you always would tease with those images. You had to tease out those wavelets.
Come here, you. Come here.
Come on.
Come on, little wavelet. I'm going to Fourier transform you out.
That is awesome. I love the detail in there. And then, Nicole, do you have Mr. McGee's?
I do.
Because that was awesome sauce, too.
Oh, yeah, the Jupiter.
Yes.
Oh, I have a tiny version. That's not fun. You'll have to tell me. I just opened it and it's tiny. I didn't get the high-resolution version. I don't know how it looks on the screen.
But still, let me put that up here.
Yeah, no, I just grabbed it out of the event page, and it only gave me the tiny version, because thinking. But yeah, that is a awesome, that's like, I love the colors in this one, this Jupiter picture. Oh, here's the big version.
Yeah, it's going to be a 9 megabyte image file, if you want to grab the
okay. I'm using my campus internet, it's fine.
But no, thank you, James. And I see you put another one up here as well, as far as with your moon.
There we go.
Which is
Here's
amazing.
Here's Jupiter again. This is the larger one.
There you go.
But yeah, it's I just like the colors in this one. It's kind of bluish, and it really kind of brings out the dark.
Wait, does that mean it's coming towards us? What's happening, guys?
Actually, at this point, it's heading away, right? Because I mean, we're past opposition. So until next year, Jupiter.
We'll miss you. I know you're blue. We'll miss you, though.
So long, and thanks for all the clouds.
Yes.
Oh.
So, Peter's here. Can you hear us, Peter?
Yes, I can.
I can hear you. Welcome.
Right, good. Sorry about that.
There's a moon.
I went to my backup laptop just as I was getting no voice out of the other one. I'm not sure why. So anyway, I'm here.
How are you? Are you doing well?
I'm very well, thank you. Yeah, it's a busy time of the year.
Yeah, definitely. Mm-hmm. So, in case anyone missed, my good friend Peter and I, along with Shaw, we had the world's first ever live observation of an exoplanet transit. So,
unbelievable.
Cool.
Peter is amazing, and we got it set up where he was able to, from Australia, remote operate a telescope in New Mexico. Am I correct with that? And we observed a planet passing in front of its host star 550 light years away, and was able to share it with everyone live. It is up, I believe, on Peter's stream on Google+, so you should be able to check in here later to see who was in the hangout. It'll be Peter Lake. But we had a blast of a time and did the photometry data. Did you want to share a little bit as far as what equipment you use for that and how often you actually do this on a daily time? This was your first time doing this.
Yeah, so it was a good session. Just lining up on the Andromeda Galaxy at the moment. So.
Oh, very nice.
Oh, you're observing right now. Sweet. Yay, nighttime.
And actually, that'd be great. We can actually end on the Andromeda Galaxy, which is wonderful.
Isn't that what we usually start with?
Yeah.
Yeah, Gary usually has it up at this time of year first. But I mean, here in LA, well, I mean, Scott can attest to this too. We are under lots of clouds.
Yes, we are.
People are sharing awesome stuff.
You guys are awesome.
On the event, okay, except for that one. There are some really great pictures. We've got a couple of the Orion Nebula.
And Anthony, I'm sorry, but I'm gonna have to go and delete that one, sir.
It did make me laugh, though. This one looks like Orion from Sam Piles, and I don't know what's in the foreground, but something is lit with red light. I don't know if that's a telescope or a dome or a building. Just this is all on the event page. Oh, that's a gorgeous moon.
Yes. Was that James McGee's again?
Yeah, that's James's. Yeah.
You're just showing off. Just showing off.
Show off.
Hey,
and
I
there's
like
a
show
movie.
off
There's a movie by Dave Noble. Looks like a movie. I haven't tried to play it yet in case it breaks my computer. What the hell? Press play. It is a sequence of Jupiter images with Io and the Great Red Spot going across.
You should show it off instead of talking about it.
I know. I'm keeping it all to myself.
I know, you're so mean. What about the people on CosmoQuest? They can't see these.
Hang on.
Why are you so rude, Nicole?
Oh my god! Oh my god! I'm screen sharing. Shush! Screen sharing. There you go. Can you see it?
Yes. Can you full screen it?
No. Maybe?
Can you please? Yes.
Did it do it? Is it full screen?
You and blackened it.
Damn it. Full screen doesn't work. But yeah. Oh, red spot! There we go. That's so cool.
That is really awesome. So for all of our friends on CosmoQuest.org that are watching this embedded, please feel free to jump in and take a look at these awesome contributed images on the Google Plus event page for Virtual Star.
And our YouTube viewers as well. Yeah.
Yes.
Yeah, go to the event page because we are seeing some people are posting some really awesome pictures and I can't get to them all. Oh my god.
Can't get to them all.
Orion Nebula, got an Iridium Flare. These are fun. You guys are awesome. I can't do jack with the telescope, let me tell you. Like, that's why I show you guys my radio blobs, because... Oh, damn it. That's why I show you guys my radio telescope blobs.
I love
because
you.
I can't use a video. Shut up! Wait, like, this is about the prettiest thing
I don't love you anymore.
Look. This is like the prettiest thing I can show you, is these blobs. And we've actually used the word blob in a scientific paper.
Nice. Now, if you were Fraser, would that be blobs?
These are the blobs from this is another jet, a supermassive black hole jet, but this is an one. This is something that I studied called compact symmetric objects, but I used the Very Long Baseline Array, which is a telescope. It's a series of radio telescopes that goes across the continent, like, of North America, and you make blobs. And you learn science, and they're not that pretty when it comes to visual-looking images. But we did some pretty cool science studying these baby radio jets, these little baby versions of the Cygnus A thing I showed you earlier, and learned some properties about it.
Very nice.
So yeah, blobs. That's as pretty as mine get.
It is, but that's a pretty blob.
There's
lots of magenta on that.
That was the spectral index plot, if you really want to get dorky.
Now, Peter, what are you showing us right now? Because I love it. What is your fisheye lens showing us?
So I've got the all-sky camera up there at the moment, and I'm just about to share with you the Andromeda Galaxy. Got the first image in, so let's put that one up. And you may not actually recognize this as the Andromeda Galaxy because this is such a deep sky shot. We're only going to get so there you go. You can pop that up in the big screen there.
Yeah.
I gotta tilt, but
yeah, so you can actually see the dust lanes there quite beautifully.
Yeah.
So.
Oh my god. So yeah, just like tilt your head. Well, this or whatever way is different. I think this way. And then look at your Mac desktop background, and that's the picture. Except they took out the dwarf galaxies because I don't know why.
Which is odd.
Yeah.
Come on,
They thought they looked fake, like the dwarf galaxy. Yeah, and you can see. Oh, that's so cool. You can see the dust lanes, which
very
is
clearly.
The feature of a spiral galaxy is you see these spiral arms, you see the new forming stars, and you see the dust left over as these stars go supernova and blast their dust out into the rest of the galaxy. So you see that in the disks of spiral galaxies, which is really cool. And it is so finely detailed.
Now, how long of an exposure is that? Peter?
Peter?
Sorry, I was muting. Yeah, 300 seconds. Yeah.
Okay, very good.
So
Wow.
5-minute
5 minute
exposure.
image. Yeah.
Oh, I love it.
So, I'm gonna let's just see what have we got any other. I think M33 could be the next one. Let's just have a look here.
All right.
See what's...
Can you tell us a little bit about the telescope in New Mexico that you're using?
Yeah, sure. Just let me get this started so that we.
And while that's going on, I'm going to do what I was planning to earlier about looking back. So I'm looking at Andromeda right now, but we can turn around. And
Are you in Celestia? Okay.
I am.
Celestia.
So let's go to the Milky Way. Hello, Milky Way.
What? Wait, we were in the solar system just before.
Yeah, no, I'm looking
What
at
happened?
We're in Andromeda right now.
Okay.
So there's M110. There's the satellite galaxy. Hey, I go. Someone wants to go 0.5 the speed of light. No, I'm going to galaxies like this.
It took Stargate how many seasons to do that?
Right.
Sorry, the Perseus galaxy. Yeah, whatever. It's Andromeda.
No, I'm not seeing too much of a barred spiral in that then.
No, that's
It's not barred enough.
it's a shame. We have this figured out by now. It's as
I
of
see
the
the
90s.
Sagittarius dwarf.
Yeah.
Oh my God! It's actually labeled the Sagittarius dwarf. That makes me so happy.
And then you can see the Magellanic Clouds.
Yeah, but everyone does those. The Sagittarius dwarf is cool
It is cool.
because it's being ripped apart as it spirals into the Milky Way. Sorry, I went to UVA. That was a big deal.
Oh, so here we go. Here's Peter's image.
Peter's telescope.
So he's got a tiny little telescope.
Yes,
Right?
yes, it's quite a beast, isn't it? It's Planewave is a really great brand of telescope. It's really doing quite well at the moment. It's a catadioptic CDK. I think that's a catadioptic Dalkirkham array. Yeah, that's right. It's similar to an SCT, but it's quite. So it's got a 0.5 meter mirror on it,
Nice.
and a focal length of about. Off the top of my head, I can't remember.
8 light years.
Oh, let me check my mouse mat here. I think it's because I know all you telescope lovers, you like the. So here we go. Focal length of 2260 millimeters. So that's 2.2 meters. F4.5 because it's got a 0.66 focal reducer on it. And it has a field of view of 35 by 23 arc minutes.
Oh, wow.
Plate scale of 0.82 arc seconds per pixel. And it's got the full range of astronomic and photometric filters on it. With the, we might even have a go at a hydrogen alpha a little later. But yeah, it's really quite a piece of. It's got a nice Finger Lakes camera, PL11002, which has got a Class 1 sensor on it. So, it's a serious telescope, and
It's serious business.
Yeah, so
Unlike this star party.
To be honest, I get about 15 hours a month on it because that's all I can manage. But other people use it when I'm not using it, so it does about 70 hours of science.
Oh, that's awesome.
Very good.
So.
Very good.
And speaking of science, let me see if I can bring this over.
Speaking of
So this is the result of our hangout with Peter.
Oh, nice.
You might just want to maximize your screen again, Scott.
Oh, yeah.
Yep.
There we go. So give us a brief little tale of what we are seeing here from the Star Guitar 1, and this is the Guitar 1B of the transit of it. You want to give us a brief overview of what we actually accomplished there?
Sorry, I didn't catch that. The voice was breaking up a little.
Oh, it's okay. So this is our graph that we got at the end of it. So if you want to explain to our audience actually what we're seeing here when we're looking at this graph, these different plotted points, and what we're actually seeing, what are we measuring here, and what does it mean when we're talking about the transit of an exoplanet?
Sorry, I could hardly make out what you were saying.
Okay.
Okay.
Yeah. Yeah, we come across the Pacific, so sometimes the codec takes a little while to sync up. The codec's pretty good on this, but every now and then the voice breaks up a little bit. Do you want to try that again?
Yeah, I would just ask you to explain the photometry that we saw with our transit.
Yeah. So when was it? It was about 2 weeks ago now we did it, wasn't it?
Yeah, a little over a week ago.
I'll see if I can grab the, where was the image of our light curve the other day? I've got it here somewhere.
Is it the one Scott is sharing?
Yeah, Scott is currently sharing the light curve, so it's visible to the viewers.
Slow internet.
Something's locked up there.
Scott, do you know is that line a fit to those dots, or is that a model?
Because I actually didn't run this data, but I believe it was the second one on the bottom is the trend removed, and it's the original data up top. And I believe it's just going to be the best fit inside those.
So it is a fit. It's not a model.
Right. I don't know because I didn't run it, so I'm waiting for Peter to get in here. But it was really exciting because as we went along, we were actually able to see the plotted points. We were able to see the magnitude change as we're observing this, and it was just wonderful because this is some science actually being done that we're normally seeing pretty pictures of online. And during our virtual star parties, we're actually able to do some science. We're actually measuring the luminosity of something and watching the stars change due to an object flying in front of it.
I can simulate this with my smartphone right now. Just give me a sec. So if you're looking at a star, and the star's not a rectangle, it's actually a sphere. But ignore that for a moment. And if you're measuring how much light is coming off the screen of this star, the light coming from the star, that's the plot points that he's showing there. So at each time point, they're measuring how much light is coming off the star with some precision. There's little error bars on there to tell you how precise they were. Now, if an exoplanet comes in front of the star, so here's my little exoplanet, and the little exoplanet blocks the light from the star, and so there's less light coming from the star overall. Now remember, it's not here according to your telescope. It's a tiny, tiny, tiny point of light so far away you can't actually see it. But the amount of light you measure from the star actually is smaller. It dims. It drops down a little bit as the exoplanet as the exoplanet pops in front of it. And you see it even it dips down as part of the planet comes across, and then it's fully down as the planet is completely on the disk, and then it starts to slowly go back up to its normal brightness as the planet goes away from the disk. So I guess if you imagine the brightness of my face, I guess that kind of works. I'm pale enough.
The albedo of your face.
The albedo of my face. and the exoplanet of sticky note that I crumpled up into a ball just now. That actually, so if you were measuring the total brightness coming off my face and plotted that as one plot point in time, that changes as the little exoplanet transits across.
Yes.
So that's the basic explanation of what you're seeing. And yeah, when you do science, you're less likely to end up with pretty pictures and more likely to end up with plots with dots and lines on it, like you just saw. Yeah. That's where the meat of the science is. And the fact that you guys did that in real time is just incredible. I was traveling, so I couldn't watch live, but it was just incredible.
No, it was a great time, and I think Scott's graphics might have stole the show as well. He did a very good job zooming in on it from away. So anyway, I think you provided a link to it on CosmoQuest in your Scots for anyone who wanted to have a look at the broadcast. So it was. I have downloaded it, so I can send you a copy if you want to edit up a highlights package or something. That'll be good.
Cool.
Absolutely. Yeah, I believe Joe put it up on the Astrosphere Vids, but I think it'd be a good. We'll go ahead and share it out later on tonight because it was the first time it's ever been done. And I think it's really important to show what this amazing science can be done by if you just have some resources available to you. You don't have to be in a dark dungeon lab like Nicole is underneath the university to be doing this research. You can do research no matter where you are, whether it be through CosmoQuest, doing craters, or you can actually do some photometry. And I believe, Peter, you were sending yours off to a research group in Russia, I believe.
Yes, correct. There's a it's funny, and it's a good story about citizen science. When amateurs get involved in this kind of thing, there was a famous amateur astronomer who had a bit of a cult following amongst the exoplanet hunters. His name is Bruce Gary, and he built a database of transits and things of a number of exoplanets, and wrote up a book and a process of how amateurs could do that. And if you just do a search for that, you can find it online. And he handed all his body of work over to the Czechoslovakian Astronomy Society, and they created a thing called the Treska database, which is the transit and variable star. Can't remember all the letters of the acronym there, but so what you can do is you can put in the coordinates where your telescope is, and it'll give you a list of everything that's transiting that night, and then you can pick one out that's suitable for your equipment. Some obviously are deeper transits than others, so and then you can upload your raw data once you finish. It does a model fit of the data and gets reviewed by some of the people who run the database, and then added to the collective body of work. And
that's awesome.
So I thought, so what I initially did was I took the Kepler public data and I stack ranked it by transits that weren't too long and anything above about 13 millimagnitude, which is what I thought I could get to, and it produced a list of exoplanets. I started work on one of the Kepler transiting targets that no one else was interested in, until someone pinged me and said, well, actually, we're interested in that one too, so how about we work together? And since then, this specific scientist at Pulkovo University, I think it's Petersburg or something in Russia there, they are looking at transit timing variations, so I'm helping them just gather a bit of extra data. They've got a couple of their own telescopes, but they like other astronomers, providing data as well. So I think some people call it peer review. Is that right, Nicole?
Not until you feel like your soul's been ripped out.
Yes.
I mean, what? No, it's wonderful.
Well, I think that's actually a great place for us to end, to show that it's not the peer review point, Nicole, but just the fact that we all have our way of contributing, and we can follow that curiosity to actually accomplish something and be able to be a part of a community of just learning more about the universe. So regardless of where you are, if you want to do some research at home with the CosmoQuest and your fuzzy bunny slippers, or if you want to get into doing some photometry data, and there's many other ways of actually contributing to scientific research across the internet, and actually in some local places too. So go out there and do some awesome stuff.
Yeah, I want to note I just posted a blog post on CosmoQuest about some of the non-astronomy citizen science projects I was introduced to at the AGU conference. So if you are into being a naturalist, if you want to go look at all the little critters in your yard and actually, or on hikes, plant life, things that actually contribute to biology, to climate change science, all of these, there are lots of citizen science projects out there that are not just astronomy. So if you're an outdoorsy person and you just don't want to be sitting in front of, with your bunny slippers, there's non-astronomy projects as well. And so definitely check out that at cosmoquest.org/blog.
Awesome.
And we have another galaxy. We need to end on a galaxy.
All right.
Peter has a galaxy.
Yeah, so this is M33. M33. You might want to. I think it's. I'm trying to think of its common name.
It's the Triangulum Galaxy.
Triangulum. Sorry, yes,
So.
that's right. Yeah.
And it involves my favorite word in astronomy because this spiral is flocculent.
Flocculent, yes.
They're messy spiral arms. They're like sheep fluff, and so they're flocculent.
Awesome. Well, thank you, everyone, and Nicole, because you're not in everyone right now, and I love you. But thank you, everyone, for showing up.
What happens when Pamela and Fraser go on a cruise?
And there's another week of this, guys. Hopefully next week we'll have some more telescopes. Thank you, Teale, for jumping in last minute, and Peter for being able to jump in at the very end of our show to share your views from Australia, even though you are sharing New Mexico. So we do have both people in Australia just sharing different parts of the world, which I think is awesome. Thad as well, thank you for hopping in for your awesome commentary. You want to share real quick who you are before we sign off?
Sure, yeah. My name's Thad Szabo. I'm a professor of astronomy and physics at Cerritos College here in Southern California. So, yeah, I've just been doing the VSP here for a couple of months with you guys. I know I hung out with Nicole when I was out in the desert freezing my butt off. And it was
fun for me. I was warm.
Oh, no, it was fun for me, too. It was just, kind of interesting trying to see what I could get. I did get this shot.
Great.
I did get this shot while I was out there.
Ooh, ooh, ooh.
Oh, nice.
So, trying to test whether I could get the Rosette Nebula. So,
I would say that is confirmed. You did get the Rosette Nebula.
Well, it really needs 4 panels, right? I mean, this is one field of view with the camera and telescope setup I have. So it looks like I'll need about 4 of them to get the full thing, because this is a pretty huge region of the sky that this takes up. So.
Right.
Yeah. So thank you everyone for watching, even though pretty much all of our telescopes were clouded out.
But no, it's been fun, and
awesome.
We bring the silly when stuff goes.
Mine wasn't.
It was a lot of fun. Again, Teale, Peter, you guys are awesome. Thank you for showing up.
Yeah, thanks.
And we will see everyone later. There will be some more hangouts later on this week.
Let's go through the calendar. There's no astronomy cast tomorrow because Pamela and Fraser are on a boat. So with very very limited internet.
Yes.
But we will definitely be the Planetary Society will be having their weekly hangout. They just started that a couple weeks ago on Thursday at some time, your local time. I have 2 o'clock Central. I don't know what time zones you all are in.
Yes.
But Planetary Society hangout. And then a time as yet to be announced, we will be celebrating that the world is not ending even though we're not on a boat.
Right.
All of you who couldn't afford the cruise like us, all of us, we will be hanging out with a Google Hangout at some point on the 21st.
Yeah, throughout the entire day, there's going to actually be a few hangouts going on. We'll be bouncing in and out of many of them. It's almost a surprise. We'll let you guys know what's going on when it's going down, but we're going to have a lot of fun and, again, bring the silly science because, well, we love science and we can rarely be serious. So thank you, everyone, for coming out tonight, and see you next week.